All right, so here's the problem I sort of scribbled out in a hurry at the end of the period yesterday, end of the class yesterday. Everybody saw, so we could try to get ready for this test on Monday. And it's all about gases, and it says my truck, let's see, produced 975.3 liters of CO2 at 80 degrees C in 1 atmosphere. Wants to know what amount of CO2 is produced. So let's make our list of knowns and unknowns. Same process, same solution process. The way we solve these starts out exactly the same for every kind of gas law problem. We're going to make a list of knowns and unknowns. So we know the volume. Volume is 975.3 liters. Okay? We know the temperature. Temperature is 80.0 degrees C. Now I know I'll have to do that in Kelvin, so I'm going to leave a little space to put that in there. I know that it's at 1.02 atmospheres. Now if I didn't know that that was a measurement of pressure, I could go over here and look on the front page of my test references and see pressure units have all these different units. I can see right there atmospheres or kilopascals or torr or millimeters of mercury. All those are ways of measuring pressure and figure out that this is a pressure unit. Okay? It's asking me what amount of gas is produced. You need to know that the SI unit for the amount of a substance, this is unit 1 stuff. Okay, in unit 1 we said the amount of a substance is measured in moles. So we're going to do N is the symbol used for that. N is the amount of a substance. And we're going to find the answer in moles. So we're going to look for moles as our answer. All right. Let's see. I do a couple things. I think I'm going ahead and change this over to Kelvin temperature. So what I have to do here is take 80.0 degrees C and add 273.15 to that to get it into Kelvin temperature. And I see 5 and 1 and 3, and this is 15, so 353.15. But there's an empty slot right here, so that 5 has to be rounded off. And the actual temperature we're going to use, because we have to have it in Kelvin, is 353. This 5 makes the 1 round up to a 2, so 53.2 Kelvin. Okay. Say, did you finish that problem at home? The one I gave you at the end of the period yesterday? Well, we're grading it. If you have it, you need to exchange it with somebody. Okay. Or bring it to me and I'll grade it. 353.2 K. All right? So now we're going to go and find our list of gas laws and see if we can find a gas law that has those kinds of variables. Okay? So here's the list of gas laws. They're all on the test references right in this section. And I'm looking for something that has volume, temperature, pressure, moles. And there's one that has volume, temperature, pressure, and moles. But it also needs R. And you have to know that R is always there. You always have R. Everybody has R. Okay? Everybody has fingers and toes and eyes, and everybody has R. Okay? All right, let me make a check here on this real quick. Where did I put that list? Oh, here it is. Okay. Okay, Sadie, you can have this back. This is a practice test. Can you pass that back real quick? All right, so the equation we're going to use is going to be PV equals nRT. That's the gas law we were looking at a minute ago. Okay, so PV equals nRT is right here. But we still have to find R, and all we have to do to find R is to find the version of R on the front page. The front page of the test references, down here at the bottom, and find the version that matches these knowns and unknowns, these measurement units. So we got liters, Kelvin temperature, atmospheres. And that's the version of R right there that has liters, Kelvin temperature, and atmospheres. And we said we're trying to find N, the amount of substance measured in moles, and there's moles. So, yes. Well, you can bring it here and I'll grade it, or if nobody's willing to exchange what they got already with you.
Yeah.
Well, I'm not asking it to be right necessarily. I'm just asking to make a reasonable attempt to solve the problem. Okay, so R then is going to be this number, 0.08206 liters times atmospheres over Kelvin times moles. Okay? All right. Now at this point, what I've taught you in this class is you substitute the known values into this equation. Okay, that's the way I taught you originally up until yesterday when I said there is one thing you can do here that's a little bit different if you choose. So we can either plug in all the known values into this equation and then isolate the unknown. The change is we can isolate the unknown first and then plug in the values. So I'm going to let you vote as a class as to which direction you want to go. All right, so the first thing I want to ask, so you got two choices. Isolate the unknown first or plug in first. Does you understand the choices? All right. How many of you want to isolate the unknown first? Raise your hand. Nobody. Okay. So I assume we're going to do the other one. We're going to plug in first. All right. So we got pressure is 1.02 atmospheres. So 1.02 atmospheres is the pressure. Okay. Pressure. And we're going to multiply that times volume, which is 975.3 liters. Okay, so we're plugging in what we know, but we don't know N, so we're going to leave N alone. Okay, going to leave N as N. And then we're going to multiply times R. The version of R we're going to use is this one, 0.08206 liters times atmospheres over, I'm sorry, that line shouldn't go over there, Kelvin times moles. Now, if you're not writing this down with me, you're probably wasting some time. There's no reason for me to wait till I'm done to write this down. You should be taking notes on this as I do it. Okay, I shouldn't have made this line go all the way over there. I want to use something I tell you guys not to use. It's whiteout. At least not in your lab notebooks. You're not supposed to use whiteout in your lab notebooks. Okay? All right, so that's R. And then the last unknown we have, or the last variable we have, is T, and we know it. And that's 353.2 K. All right, so I plugged in all the knowns into the equation. So the next thing I got to do is try to get N all by itself. Now to get N by itself, I need to multiply this side of the equation by the inverse of this. The inverse is a fraction where you flip everything, and the inverse of this. This is not yet a fraction, so I'm put it over 1. Putting it over 1 doesn't change the amount, but it makes it easier for you to see how to invert it. Okay? Now I want to use a slightly smaller pen because I'm running out of space over here. So this takes up a lot of space to get it all done. So let's flip this one first. So we're going to have Kelvin times moles on the top. So I'm flipping this one. And 0.08206 liters times atmospheres on the bottom. Okay, so I flipped this one and multiplied there. I got to flip this one too. So I'll put 1 on the top here, and 353.2 K. Alright, what I do to this side of the equation, I have to do to this side of the equation over here. So let's flip that over here as well. So we got 1 over 353.2 K, 1 over 353.2 K. And then I got to put this one in. This is a new one as well. So both of these are things I added right here to this side of the equation. I got to add the same two things over here. Okay. So we got to add that one now. So Kelvin times moles over 0.08206 times Kelvin times moles. Alright. Alright, so we've done all the inverting and multiplying. To make all the math work out nice and easy for us, let's also put these two things over 1. Remember, putting it over 1 doesn't change anything. What now? Oh, you're right. Yeah, Kelvin and moles were on the top, didn't it? Okay. So you're right, liters times atmospheres. Okay, got that? All right, so now we can go through and cancel. I've got 0.08206 here and 0.08206 here. If they're the same on the top and bottom, or I've got a series of fractions like this, those can cancel. Okay? I've got liters on the top and liters on the bottom, those can cancel. Atmospheres on the top and atmospheres on the bottom, those can cancel. Kelvin on the bottom here and Kelvin on the top, those can cancel. Moles, top and bottom, those can cancel. I've got Kelvin here and Kelvin here, those can cancel. And these two numbers, 353.2, they're the same, so those can cancel out. So I've got all of this canceled out, and I've left the number of moles, or the amount of substance, by itself. So that's what I want to do in this stage. I want to isolate the unknown. I've got N by itself, that's the unknown, we've isolated it. On the other side of the equation, then we need to start canceling what units we can. So I've got liters on the top of this fraction, liters on the bottom here, those cancel. Atmospheres, they're on the top and bottom, those can cancel. Kelvins on the top and bottom, that can cancel. Moles is left. Moles measures the amount of a substance. N stands for the amount of substance. Moles measures it, so we must have set it up right. We've got moles left. Okay, so we're ready to do the math now. So this is where we need a calculator. Alright, so we're going to take this number, 1.02, multiply by 975.3, and we're going to hit enter. Okay? And then we're going to, after we multiplied and hit enter here, we're going to divide by this, divide 0.08206, enter, and then we're going to divide by this, divide by 353.2, enter, and there's the answer we're looking for. Okay? At least before we round it off, it's the answer we're looking for. So we got 34.32307,493. Units we have left are moles, and that equals N. That's what we have left over on this side of the equation. And so now we have to round it off to match the least number of significant digits in the measured or calculated numbers in the problem. I've got four significant digits in this number, 4 here, 3 significant digits here, and 4 here. So this number has the least number of significant digits, and that means our final answer needs to have that same number of digits. So we're going to underline after the first 3 significant digits, underline from the 2 all the way over, draw an arrow. The underlining shows those are insignificant digits. The arrow shows this is a mathematical operation in which we round off to the answer that is 34.3 moles. And that equals N. That's our final answer. Okay? How did we do? Huh? Okay, well, does this help you figure out what you left out? Okay. When we multiply, how do we multiply this stuff? Okay. You're going to take everything on the top of the fractions. So this doesn't have to be multiplied. You don't multiply 1 because it gives you the same answer. So you can multiply these two numbers here. Okay, that's what I did right there. Multiply them together. Okay? Multiply them together and got that answer. Then I hit my divide button here and divided by 0.08206. And I hit enter again down here. Then I'd hit divide again and put in this second number and divide it by that number to get the final answer. It's just a faster way to use your calculator in a hurry. You don't have to do it that way, but you have to be careful not to mix up operations. Some calculators do it pretty well and some require some other things, and it's just easier if you just do it that way all the time. You can almost always be sure you're going to get the right answer. Okay?